Hey everyone, welcome to the channel, and in today's video I am very excited to showcase you a full stack application that I built using real industry level architecture, the same kind you will find in the top MNCs, FAANG, product based companies. This is not a simple normal CRUD app, rather it's built around microservices, AI integration, messaging queue, asynchronous communication, Dockerization, central logging and lot more. We will discussing each and everything, detail how it is working, and the goal here is clean architecture, scalability and the best coding practices, not just the features. And yes, the entire project will be available on GitHub, so you can fork it, explore it, break it and fix it, and even contribute your own features. Alright, let's talk about the technology stack, but in a simple way. So first of all, in the backend I have used Spring Boot and Java, and for the authentication I have used JWT Authentication along with Spring Security, and we have also AI integration and we are communicating to Google Gemini directly. And to maintain the clean code architecture I have used Lombok, Jakarta Validations, ORM using the JPA, which is along with the Hibernate, and then I am also using SLA4j and much more things that we will be looking when will be checking the code. If I talk about the architecture part, it's completely microservice architecture, and along with the asynchronous communication with help of Kafka, and everything is Dockerized. We are also communicating via gateway, which is a Spring Cloud gateway, and all our services will only be available via gateway to the external world. And apart from that, as it is a microservice architecture, we have lot of logs and will be everything distributed, so we need a central logging system as well. So for that I have used ELK stack, and to bind all everything combined and present it to the user, so I have created a front end as well. The front end is built using React.js, and routing was also implemented with the help of JWT security handling as well, and the website is completely responsive. And the build tool I have used is White, and for designing purpose I have used Tailwind, and also I am using local storage as well to store the authentication details in the memory. And as all the services are Dockerized, so it could be little difficult to start them manually one by one. So I have created a Docker compose file as well, and it is using all the credentials and values directly from the environment variable file, which is a great practice and commonly used in the top production level architecture applications. We would be discussing everything in the code wise in depth in further videos, but for now we will be starting with the architecture, how exactly our application flows and how the user interface is looking, and we'll run the application and see how it works exactly. So let's begin with the flow of the application, how it is working. So this is the front end, and it is built using React as I mentioned, and it will request to our backend system, and it will first of all go to the gateway service. And if you notice in the diagram as well, I have mentioned that each of these services are running inside a Docker container, and even the Kafka and MySQL are also Dockerized. So the very first step, the user will be using our front end application, and using that front end application it will triggering our backend. So the request will go to our gateway service, as it will act as a single entry point for all our microservices. And once the request reaches the gateway, it will forward that request to auth service, no matter what request it is. It will first of all go to the auth service for authentication. Once it is authenticated, then it will return the user related details to the gateway service added to the original request, so that all other microservices are well known that which particular user has requested for that, and it will be added in the headers, so it is very easy to forward that data to all the microservices. So exactly, if we see, the request goes to the gateway, then it goes to the auth service, it is authenticated and the details are returned to the gateway, then it will add that details in the header and forward the original request to the respective service. It could be a user service request, it could be a chatbot service request or expense service request as well. Let's talk about the auth service first. So first of all, we already discussed that it will authenticate the things. Okay, perfect. Then apart from that, it can also log in and register, because that's also the part of authentication system as well. So if a new user comes and tries to register in our application, then its credential will be saved to the database, and an event will be produced to Kafka, so that all the user related details apart from the authentication details, for example name, its user ID, phone number, address and all other stuff, will be sent to the Kafka, which will be later listened by or consumed by user service, and then all those details will be stored in a different database. And why is it necessary? It is the segregation of data. So, and if you're thinking why I'm using such architecture, because it helps me segregating the user details from authentication details. And for all other requests, it will be forwarded to respective services. Okay, so let's start with chatbot service. That's the most interesting and highlight of this application. So whenever our frontend will receive a transaction SMS, it will send it to our gateway system, and then we will be passing it to chatbot servers. Then it will be forwarded to Gemini. And why do we need Gemini for this? Because if you notice that each and every transaction message is in a different format. No matter, it could be a different bank, it could be a different merchant. So we have a difficulty to extract the details out of that. Maybe we can use the regular expression, but it could be very vast, so it is very difficult to pinpoint some detailed value. So instead I have used chatbot service, which will forward our SMS to Google Gemini, which is a very intelligent system, we know. So it will parse all the content and will return to a chatbot service in a readable manner that our system can read and understand, and we will be focusing only those values that are important to us, but in a structured format. And once our system chatbot service gets the response, it will push that parsed content to the Kafka, and once the event is pushed to the Kafka, the expense service will be listening to that topic and will be consumed it, and that particular expense will be stored into the MySQL database. So we have a completely segregation of the responsibilities. This particular service is totally responsible to communicating to Gemini only, and expense service is completely responsible for storing and reading the expenses from the database. And similarly for the auth service and user service, all services has their responsibilities tight and does follow the segregation rules. So that is all about the architecture and the flow of the application. Just let me do a quick recap of the entire flow. So in the very first step, the front end will request to the gateway service, which is a single entry point of entire backend microservice architecture. It will go to the auth service. Once authenticated, it will return all the user details, and which will be added up into the original request, then will be forwarded to the respective microservice that was requested, and accordingly the response will be forwarded back to the front end. So that is all about this, and let's jump into the application demo, how it is looking and what we have built. So this is the front end, and we have got a login page, and this is our experience tracker application, and we are landing into the login page in the very first because I haven't logged in. And we can see our entire backend system is also running in the container, and each and every service is running in a different container, and it's all combined with the help of Docker compose file, and we can start and terminate this all the services all at once. So all the services are up and running: gateway service, chatbot service, expense, auth, user, MySQL, and Kafka. Okay, perfect. So as we are already landed into the login screen, just suppose I don't log in into the system, but I try to reach the dashboard. Should that happen? Obviously not. Let's check that. So if you notice that I tried to get into the dashboard page, but it automatically redirected to me into the login screen as I am not logged in. So let's try logging in, but I don't have an account for now. Let's try registering it. Okay, just give me a minute, I will fill all the details. So I have done with filling all the details. So if you notice that the password is very small length, even if I hover this particular, it will show a message that please lengthen this message, and if I ignore and register it, it will force me to do so. So we have a front-end validation as well. So let me just increase the password length, and let's try registering it. Perfect, we are able to register the new user. So now we have successfully landed to the dashboard screen, and now we can enter a transaction SMS over here, which will go to our backend system, then to our Gemini. Let's have a try how it works. So I have pasted a random SMS. Okay, so as per this SMS, we have spent 450 rupees in the amazon.com.in and this particular date. So let's try parsing it. If I hit the parse button, it will take some time as it is going to Google Gemini. So you can see the transaction is successful, and we have this particular amount and merchant name, and all these details have been successfully parsed. If I refresh, we can see our expense over here, And what if we have a different format? We can check that as well. So you can notice that this is an entire different format, and this is transaction of about this much amount and this particular date, and this is also from Amazon India. Then we'll be trying to parse it. Let's see what happens. And see, no matter what format it is, our intelligent system will automatically parse the details and will be sending us back, using which we can easily save it into our database. Let's refresh that, and that's our total expense. Let's jump into the code, what we have done over here. In the very first, we have a Docker compose file in which we have been starting all the containers, the Kafka, MySQL. Okay, and if you just notice, each and every services is using our dynamic values, and it is coming from env file. Okay, and this is considered a very good practice and recommended one in the production level application as well, as if you want to change any value, you need not to rebuild the application and redeploy it, rather just change in the environment variable and restart the application. It does all the job. Okay, so let's see all the services in little bit overview. We'll be discussing those in detail in the further videos. So in the auth service, we have used JWT authentication system. We'll be extracting claims and much more things. We'll see all that in the detailed depth, how it is going through, and then we'll be producing an event as well as in the register case. Then that particular event will be pushed to the Kafka, and that event will be consumed by our user service. Let's see the consumer, how it is consuming it. Then we have a listener, Kafka listener. It is the consumer thing, so it will listen and add it to the database, what we are doing. Then we have a gateway service, which is our entry point for our application, and this we have intercepted the request and also have added all these user related details and forwarding that to the original request. And by the way, these values are got from the auth service. And for the auth service, we have this. Let me show this. So from exactly this particular line, we will be triggering Google Gemini, and we will be getting a response from that, and that particular response will be extracted to our DTU and will be producing an event accordingly, and that particular event will be consumed by our expense service and will be adding to that our database. So this is how the consumer over here looks like. It will listen to that particular topic, and I've added some to-dos as well. I will be working on that. Okay, and we'll create an expense and we'll store into the database. So that is all about this application, and I will be providing the entire application into the GitHub, and you can easily clone it, fork it, or even contribute if you want. Any features from you will be also very appreciated, and would be happy enough to get your features in this project. And if you do like this video, just let me know in the comments and press the like and subscribe button, and just let me know if you are interested for the further videos. I will be creating those, and if you don't want to miss those, don't forget to subscribe, obviously. Thank you very much. Bye bye.